So we are to ascertain our position on which one is correct and why.
Yes,
I'll get you option. I presume I have not gotten you option. Can I get you the option?
you have.
Have. Has it got something to do with the theta and all?
So, no, relatively simple. Instead of five, it's the things like two and two plus root two. Only the factor of five is replaced with another number.
Vasudev, can you recollect a question which I asked you in class? If you do have any reminiscence of the same, wherein I asked that there is a wall and that wall is about, let's say, b distance, b meter or b unit distance from the foot of a person who is trying to throw a ball to surmount it.
Oh yeah, I do remember this.
And there I ask you, what will be the minimum speed? Yeah.
So, could you come again?
What will be the minimum speed and the
Hmm.
corresponding angle is then I asked.
Yes, sir.
So if you can think on that line, maybe you will be able to get something from this.
So,
What will be, though over here is not given to you B.
hmm.
B we are not aware of. From where it will be thrown is not mentioned. In my question was mentioned from where it is being thrown, and that was B. Height was H. And accordingly, we got an answer in terms of B, H, and G.
Yes.
Over here, what to do? How is that to be incorporated? Yeah, you were asking something, by the way. Please go on.
So you can instantly comment on the minimum vertical velocity, right? Because the minimum vertical distance it must travel must be h. So that you know that uy squared by 2g must be h. So from there you can get uy min.
Yeah, but then how you know that that should be the maximum height?
So that should be the minimum height, minimum maximum height it should reach, right?
Yeah, that is true, but it can graze it before of that position and go beyond it.
Yes, sure it can, but I'm just trying to set a low bound here.
Yeah, low bound per se. Low bound can be also a contention vis-a-vis tangent that you draw
So,
because the path followed is parabolic
yes.
and you're going by circle, right? You mean to say that, okay, whatever will be, the minimal is to be R. Is it so?
Yes, sir. That was my line of reasoning. Yes.
Okay. So if we take that into consideration, you will be going by maximum height, correct?
Yes, sir.
Now tell me, if you're going by maximum height, then what answer you are supposed to get from there? Then
Well,
you'll be getting under root of 4 GR, I presume,
yeah.
isn't it?
Yes, sir. So, one second. Right. So sorry, I was clarifying a doubt of Ishita. I was having some problem juggling your voice and text in the background. Could you just repeat what you said in the last moment?
Then it'll be under root of 4 GR, I presume.
So what will be under root of what here?
The speed?
So speed for what? I mean the requirement, the pretext of
Yeah.
that. I didn't catch that.
Right, isn't it? So are you going with the calculations that you have made? Are you convinced about radius of curvature?
So no, I
Are
was
you
not.
convinced about
But
maximum height?
no, my argument there was if it has the same radius of curvature as the cylinder up at that point, I mean, that's the maximum curvature of a parabola, right? At its vertex, it has its maximum curvature. So as it goes beyond that, it can't have a greater curvature than it had at its vertex. So it cannot fall back into the cylinder, right? It has to move. Uh, I mean, outside of it, has to leave the cylinder. It can't fall back in. So that was what I was saying, and I combined that with my current hypothesis about the maximum vertical height to get the answer.
Okay, may hold water. Second one,
So, but what's the actual way to solve that problem?
See, actual way to solve this problem will be to take symmetry.
Hmm.
You don't know where it is to hit.
Yes.
We are going by only one parameter, which is what radius of curvature, correct?
Yes, sir.
Now, how you are ascertaining that it cannot touch or graze before of reaching the pinnacle? You are taking pinnacle to be radius of curvature, correct?
Oh, so you're saying it might hit the cylinder, collide on it, and still go over?
Yeah.
Well,
Grazing it, it can go over the height, over the maximum, over
I
the radius of curvature taken by you, correct?
I didn't know the cylinder could interfere in the ball's trajectory, but sure, maybe that'll yield a low result.
So we have not ruled that out.
But that does complicate the analysis
Yes.
a little more.
Yeah, it does. It does. That's the reason the problem is being served to you. Symmetry, if we take, we may get, because symmetry certainly it is to maintain.
Yes.
Where it is, XY we take, and accordingly we'll delve on symmetry, is what I will tell you as of now.
Yes, so you basically just need to get it to. You just need for it to cross the line that's perpendicular to the ground and passes through the center of the cylinder. You just need to cross that. Even with zero velocity, it'll just tip over and follow the same mirroring trajectory on the other side. You just needed to cross the point.
Zero velocity it cannot be at.
Sir?
X component. Zero it cannot be at.
So I was taking the limiting case. I mean, close to zero.
Yeah. Okay. That ways.
Yes. So
This is one case.
Sir?
Huh.
Would you just
tell me
send me
the
like the formal solution to this later? Like I'll read up.
Certainly I will. Yeah, I'll be sharing with you. Don't you worry.
Yeah,
First
okay.
is this.
Sure.
Second one, which I thought you'll be able to sail through easily. What happened here? That one, which was it? The Taylor expansion one.
So which Taylor expansion?
Huh?
I don't recall seeing any problem which required a Taylor expansion. Which problem are you referring to?
Let me check which one I'm referring to. This is it. There we go. This is question. Yeah, this one, what was the number? 1.218, which I asked you to solve.
Yes, sir. I got the right answer, at least according to the answer key.
218.
Although I did have to use a calculator. I thought the use of a calculator was permissible. I mean,
1.218 is what I asked, right?
yes, sir.
What you did over here, omega you have taken, and then from there you calculated. I think I have bought with the number. Did I write you the other number?
So other number?
I have asked you for the other number as well, right? Could you please check? One more number I have furnished today. I have furnished. Try to solve that one as well.
So I didn't actually understand the context of the questions you sent today. A re-evaluation barring first and second is on the anvil. 1.131 recommendation. I didn't get what that meant. So you're frozen.
Hello, can you hear me?
Yes, I know I can, but your video is still frozen. But I suppose that's.
But I was able to hear the punctuated sound of your ceiling fan. The punctuated sound of your ceiling fan. I was able to hear. Am I okay?
Yes.
Am I audible now?
Yeah, you're audible.
That barring first and second means that those two are correct.
Mm-hmm.
Okay, and the others you need to reevaluate your answer is what I meant.
Yes, sir. The third one, the
What is-
rotating disk in the B field, I am a little bit skeptical about the answer because my answer didn't match any one of the options.
Yeah, that's fine. There's no correct option over there. It is okay. That is working is fine over there. So I'll take it. What you have got? You have got close to one of the option, right? You must have missed on two there, right?
Yes, sir, but I reevaluated this several times and got the same answer.
No, no. Reevaluation in the context that did you take all the options mentioned over there? You have assumed it to be only one option correct.
No, I solved it while assuming multiple options were correct, but yeah, I did get one option. The rest were wrong, and I do not know if they're wrong. I'm like sure an answer key here would help. Basically, that's all I'm saying.
Let let's we'll be solving. Why you require answer key? Yeah, we'll be solving them over here in the class in Toto.
When is that?
Now itself, if you want, no issues. We'll be
Okay.
solving right away.
So,
Okay. Now and what else? Yeah, the rod one. If you take, you have written in an order. What if the last one is a table? Will there be any change?
so what? The last
Kept
one?
on a table, then will there be any change?
So I have.
Basically, you're getting L by 2n, correct?
Sir?
L by 2n, twice of n. Is it so?
Yeah, L by 2, and yeah, that was my answer.
Yes. Let me now push the envelope. Slightly upscale, not upscaling, a different dispensation, let's say. If it is kept on table, then what will be your answer? Will there be any change, or you stick your neck out on the same?
So I have assumed it to be kept on a table in my answer.
Okay, if it is not kept on the table, if the lower one is flat on the surface, the
So
lowest.
then the lowest one becomes the table, basically, right?
Or if I'm keeping on table, then I'm keeping the first one halfway off the table, correct?
Yes,
Out
and
of the table.
yeah. So what I'm saying is, if you just
That
keep the
is what
entire
is,
setup on the ground, flat ground, let's say, the first
yeah,
block.
background is getting with this answer, I presume, right? L by
Yes.
2n, right?
Yes. Sir. No, no,
If it
no.
is on the
My
table and the one,
answer. Okay.
yeah,
One at a time. You go.
you go.
Right, so
Right.
I'm saying my answer is considering it being kept on the table. I've actually drawn a kind of outline of the table below the blocks. You might
Yes.
have missed that.
Yes.
So my answer,
No, no, no.
so,
Have the entire of the lower one on the table, correct?
yes,
I'm asking you to
mm,
take half of the last one out of the table.
half of the last ones, like half of the lowest block out of the table.
Yes. Yeah. Then will there be any change in the answer?
Well, yeah, because if you take half of the first block that's resting on the table or off of the table, that block is just it's just saying that you push it even a little bit more outside, it's gonna tip over,
Hmm.
right? So its center of mass is like right on the anvil of being pushed out. So if you keep any more blocks on it, you would have to stack them vertically on top of the first block. If you pushed it even a little bit to the right, the net combined center of mass would be pushed to the right, right, and gravity would pull that down, and both the blocks would trip and fall.
Okay. So in that case, the answer will be different from this one, right?
Yeah, it'll be 0 as long as the block you're talking about is not the first one.
Hmm. There will be no general formula for the case.
So I am saying it's 0. There's no requirement. It's a constant function, 0.
I couldn't get you. How will it be 0?
So wait, let me just confirm what you're saying here. Just give me 1 second. You should be able to see my screen.
Uh, I'll help you with mine. Just a minute. That camera is on now.
So can you see it?
Your screen. Yeah.
Yeah. Okay. So what I'm saying is, let this be the table, right?
Yeah.
Okay. You are professing that we keep a block this way.
Correct.
Okay. So its center of mass is right above the edge of the table, right?
Yeah.
So if we are to stack a block on top of this, we would have to stack it just above it. If we move this block even a little bit to the right, its center of mass would come here. The combined center of mass of both of these would be somewhere here. And that's I mean to the right of this line, which means gravity will pull it down, normal will push it up, both of them will create a clockwise torque and it'll fall down, tumble down. So I'm saying if we are to stack any block on top of this, it has to be just above it. And another block, if it's to come, it also has to be just above it. So the extension of the last block relative to the previous block would be 0. Unless, of course, the first block, in which case it'll be L by 2.
Okay. If I take it any figure, not L by 2, then?
Then I suppose you'd have a little more leeway with what you can do. So obviously, okay, my bad, not L by 2. Let's give ourselves a little bit more room there. So if, okay, we're talking about this, right? That's L by 2. I'll just take that to be some general L by K. So we can stack a block here as long as the combined center of mass of both of the blocks do not cross this line.
Right.
So keeping that in mind, I think we can we can stack it anywhere we want. I mean, of course, if its center of mass comes before this line, we can stack it anywhere. But then when it starts to exceed this line, the maximum we'd be able to go would be L by K this way. Because if we cross L by K, I mean this line, right? Just the symmetric of this line. If we cross it over to this side, the combined center of mass would cross this line, and again they would fall down. So you've only got maximum extension of L by K from here. So add that to this L by K, and you'll get 2L by K.
Okay. So what will be the general? There it was L by twice n, if I'm not wrong, correct?
Yes, sir.
Will there be any change here?
So, but okay. My problem is we expended all of our headroom, all the headroom we had, in the position of the center of mass in our very first placement. If we placed it at L by 2L by K, because now that the center of mass is already on this line, let me just use a different color. Yeah, now that the center of mass is already on the edge of the table, we can't place another block at least offset to the right, because again it would push the center of mass to the left and it fall down. So we'd have to be a bit, let's say, conservative with the placement of the first block, so it'll leave enough headroom for the second block. And there's a lot of ways you can do that. There's no fixed way really. But then again, you're asking for the maximum extension, right?
Yeah.
Okay, well, there's...
The order as you stated there.
Sir?
The order as you stated there.
Okay, so
if you have an order as well.
If
there you have stated an order L by twice n.
Just a second. Where was that? Seems to hold the mouse. So you're talking about this L by 2. This one, like that, as a general rule. So I think if all you're looking for is to maximize that length, there's another way we can go about this. Because okay, let's just consider that's to be our first block, and there's a center of mass. We already know that the maximum displacement the first block can have is 2L by K.
And nevertheless, you're right on this question, so I'm not to stretch. You will get time to think on this question, certainly. But let me address the questions which you are not very sure on, right?
Yeah, so what I was saying is, if you just reserve this entire 2L by K space for the last block, right? Let's say you have n blocks, right? This is the first block, and you keep stacking blocks right on top of this, right on top of this, right on top of this, until you get to the n minus 1th block, right? The center of mass is still here. And now you can possibly, I mean, this pretty much acts like a very rigid table, because all the center of masses are to the left of the line of the table. So I think if you've stacked enough blocks, maybe you can even get away with positioning the block exactly at L by 2. Maybe, if you've stacked enough blocks. It really depends on this number n minus 1 here. If not, maybe you'll get a little bit less. Maybe you'll get exactly this number, certainly more than this number. And this was the maximum possible number for having only 2 blocks. So I think that would be a valid answer.
Point taken. Now, what about the rod case? Hitting and then rotating, that one?
That one. Just a second. I'll rearrange my windows. Just keep swiping all the time. Yeah. Okay. So, are you talking about? Wait, where'd that go? This one. This one. This one.
Just one.
Yeah. So, this is actually one of the answers given in the options. So I'm pretty confident about this one.
Could you please tell me what have you taken the direction of velocity here after the hit?
They've given it upwards of V.
Yeah, that is okay. The point of hit.
So?
How will the point of hit move? The point where it hits the table.
Well, the table can only exert an upward force. Like, there's no friction, so that the only force it can act on it will always be normal to it. The center of mass will not gain any velocity in the horizontal direction. So it came vertically down. It'll move back up vertically up.
Of restitution.
Sir?
When you write coefficient of restitution, when you will write, then you have to take the normal component, correct?
Yes, sir.
So what will be direction of velocity of the point of hit? Only then I can take the normal component. Are you to say that it will move normally? The point of hit after being hit by table, will it move up vertically upwards?
So no, I didn't actually concern myself with the motion of the point of hit. I rather took a more generalized view of the entire rod. So initially, its linear momentum was mv not downwards. Finally, its linear momentum is mv upwards. So you can calculate the total impulse that this collision must have had on the rod.
Okay.
And from there,
so that you have calculated the impulse. After that, what you have done?
Yes, so once you get the impulse, you know that impulse must have been delivered by a force perpendicular to the floor, right? And you also know that impulse was delivered over a short period of time, so you can consider this. That's basically the distance of that from the center of mass for calculating the torque to be relatively constant over the time in which that force acted, and that would be L by 2 cos theta. L by 2 cos theta, yeah. So then use it.
I'm going to see your page. Could you please just a minute? I'll check your page. Could you please show me your page? Because you are referring to FDT, left side, a bit left.
Here?
A bit left. Take it a bit left.
So I can't take it a bit left. That's the end of the page. I think my screen is lagging for you.
For cos theta. Let me check what you have sent. That was having some contention. I'll bring to you.
Yes. Sure.
So we're here. So I read now. You wrote delta P you have calculated. Fine. I don't have any issues there. Torque you are calculating, and torque you have mentioned as which point of calculation you have taken?
So I'm calculating
center of
torque about center of mass.
Center of mass. So center of mass, you wrote torque, and then you wrote torque this quantity. Then you wrote L is equal to how much? L is equal to, what is this for us? Integration of this factor, dl.
Yes, sir.
dl is equal to tau d theta, change in torque.
So tau dt, not d theta. It's dt.
Tau dt. dt. Okay, and then you have L is equal to I into omega.
Yes, sir. So you still there? So I can't hear you.
Yeah, this is the problem. When I'm WhatsApp, you'll not be able to hear me. Impulsive torque is what you have calculated, correct?
Yes, sir.
So impulsive torque, you are calculating about center of mass, and you're writing impulsive torque equal to tau d theta is what you've written, which will be equal to delta L, correct? Delta L is equal to tau d theta, that is fine. And then?
So, and then I've We already know the integral f dt, so I just factored that out and substituted its value.
So L is equal to I omega. I is ml square by 12 into omega. Now, in impulsive case, dear, you're talking of impulse, right? And impulse has been calculated by you as whatever you have. You have done it absolutely correct. There is no qualms about it. In the vertical direction, fine.
Yeah.
Okay. The point where it hits will also have V, will have omega as well, right?
Yes, sir.
So it'll have V, will have omega as well. Where is the uses of coefficient of restitution? Is that an additional information to you?
So no, I think any information that would have existed about the coefficient of restitution is encapsulated in the final conditions after the collision that they provided us with. Namely, it moves upwards with a velocity of v.
So if we take in coefficient of restitution, let us say as E, then will your answer change?
Well, it shouldn't. Maybe from this we can even calculate the coefficient of restitution, the dependent variables, right?
The question is asking for coefficient of restitution, yes or no?
So
there's a mention or not?
No, there's no mention about coefficient of restitution. No.
So are you to say that it will not depend on it?
No, I'm not saying I'm not saying it won't depend on it. I'm saying it is a factor. It is playing a role just in the background, certainly not noticeably here. And we do not have to bother about that factor because they've already given us the initial and final conditions just before and just after the collision. So we use the coefficient of restitution to determine the parameters after the collision, but that's already provided to us. Why should we bother?
Okay. You have book, what is it called? You have Arihan book?
Sir?
Arihan, do you have Arihan DC Pandey?
So DC Pandey, I might have a PDF.
You may be having this. If you can I get the questions?
So questions from where exactly is questions? Is a really general request.
Rotation, unsolved.
So from which chapter? Rotation.
Yeah.
So what's the title of the book? I'll have to look it up.
Title of the book. Mechanics 2 it may be.
Sir?
Mechanics Volume 2. Pandey, Arihan publication.
Yes, I might have got a... No, that's 404. Mechanics Volume 2. Okay. Yep, I might have hit the jackpot. Yes, sir. So you wanted the unsolved rotation problems.
Yeah.
Okay. Rotational mechanics 91 to 208. Okay. So just a second, yeah, rotational mechanics. Yeah, okay, got that. Alright, it's actually a pretty good book.
Not bad either.
So just a second.
I wrote all the material of Fitzy when he left Fitzy and
Sir?
wrote a book.
What?
This was a guy who was with Fitzy and then he took the material of Fitzy when he left. Wrote the same.
Okay, I guess he didn't really like his employer. Uniform rolling. Okay, solid examples. Alright, 1 second. Almost towards the end. Okay, mechanics 2 objective questions. Exercises, level 1. Okay, there's different levels. From which level are you talking about?
Two levels.
Sir?
Level 2.
Uh,
There are two levels.
yes,
Level
okay.
2. There'll be a question. You can see the question. Rod. You will get to see rod. Yeah. Carry on. Carry on. Yeah. Somewhere you'll get rod. Carry on. Mhm.
not yet.
You'll get. Get.
So maybe we can just search it. If you remember
But then,
any keywords, we could just look for it.
the same question, the question that we are referring to, akin to it. It'll be in the second last page, the penultimate page only.
No, I
Just
actually
before of the
finished the
answers. Before
chapter.
of the answers.
The penultimate page
Okay.
before the answer does not contain a question that you're talking about. Just a second. If I can find what they're talking about. Collides with the horizontal surface. Let me just search it. Wait.
You can check my answer as well.
Well, okay. There's something wrong with the search parameters.
You can check my answer.
What is the answer to this thing? Oh, I don't think
This
it can.
one.
I don't think it can
There'll
search.
be 12.
Sir?
There'll be the answer there will be with value of V naught and V. So there'll be with 12 something 12 multiplied with. Just to bring to the answers level 2, I'll get to know.
Yes.
Answer
Sure.
of level 2 of DC Pandey.
Level 2. I think it's spelled this way. Wait a sec. No results.
Because over here it is in terms of V and V naught. I want to represent the other way around.
So I do not think it will be able to search LaTeX though.
No, it will not be able to search. You get me the answer. You show me the answer page.
Yes, sure. I was just navigating my way there. Yes. Level 1. Those are level 1. Level 2 over here. Subjective questions.
Is there 12 MV naught something? I'm going to expand it. Either 12 MV naught.
The only V naught I see is here. It does not seem related.
Not there?
Nope.
They have removed it. Okay. Fine, I'll get you. No issues.
Personally, I don't see any.
Here you're fine. No. Here I don't have any issue. Here you're okay. This actually is from material, VMC material. So this is fine. They have given you V and V naught. There it was there was no mentioning out there, and then the table just dropped from some height. It hits and then leaves.
Okay.
In that case, same being asked, that what will be the final? What the final value of omega or V point of contact that is. So if it leaves, what will be the value of V being asked, let's say? Let's formulate a question. What is the value of V of the rod after of the impact? Value of V.
Okay, so you're saying we know this much and we know the coefficient of restitution is E. We need to find V.
Fine. You can solve this question. I'll make a good solution, no issues. You can try that out.
Yes.
I'll share with you. I have in the snapshot form. I'll share it with you. You can try that one.
Yeah.
Because all my stuff are on in carton. We have not unpacked it as yet. Okay. One is this. Then why did you leave those questions? Second air questions. Were they easy?
So which
Were you
one?
able to say the electrostatic ones?
Yes, I feel the reasoning was relatively easy. You're talking about this one, right?
That's fine, right?
Yeah, that was fine.
Okay. Now you're asking for that this rotation. Yeah, this one. This one is just a minute.
This one?
The middle part is being filled. What about that one?
This one?
This one. Before the pulley, yeah, that one.
So that's also relatively easy, right? It'll be less than F naught.
Why?
It's because instead of writing 1/4 pi epsilon naught, you'll be writing 1/4 pi epsilon relative epsilon naught epsilon
No,
relatives.
dear, I'm afraid you have taken entire to be the medium. It is not about entire medium, it's about between the two charges.
So how does that change things?
The argument will not hold merit. It will change. It will
So,
certainly change.
um, okay. So, okay,
Not entirely that, yeah.
so,
Rethink. It's not entirely the material over here is just between two charges.
yes, sir. So, but my argument is they haven't given us how, I mean, how much of the space between them is occupied by this material. So that drives me to believe that the answer we get, at least the qualitative as answer we get here, does not depend on how the space between them is filled with the
Have an
dielectric and more in the
argument.
presence of the dielectric itself.
If you have an argument to place, let us say that there are n number of lines connecting the two, right?
Yes.
And when you place medium between the two charges,
Hmm.
then in that medium, the number of lines is ought to decrease, correct?
Yes.
To the medium, connecting them through the medium, number of line will decrease,
Yes.
but total number of lines should remain.
Same. Uh,
So,
so some lines. So some lines will just go the opposite direction. I mean, they'll go to infinity. I don't know.
and when infinite is infinite, right? All other terms.
Or maybe they'll just. Um, I mean, wait. So are you saying the number of field lines will reduce, or the density of field lines will reduce? The density of field lines
Density
will reduce,
is
right?
higher. Density will be higher when it's placed between the two dielectric than the density which is without of the dielectric of the number of lines connecting the two will increase, right? Number of lines, let's say number, I'm not interested with, I'm just talking about number of line which are linking with one of the charge. Can we take that into account?
Yes.
Now, when there is no medium, then number of line will be almost, let's say, symmetry, or you will have more number of line passing through the area which is to occupy medium, correct?
Yes, sir.
Then otherwise, right? If there is
Yes.
medium, then that number will decrease, but which number will increase? The other number will increase, correct?
So the other number?
The other number which is not between the medium.
So one
Density.
second. So once again, I have it out here. So you're saying you've kept two charges some distance apart, and and you filled some portion of the space between them with a dielectric. Now this dielectric extends till infinity, right? There's no way the field lines can get from one side of the dielectric to the other side of the dielectric without crossing the dielectric.
Correct.
So,
Referring to the density in the area bereft of dielectric.
yes.
Density of the lines.
Hmm.
Density of the lines in the area which is bereft of dielectric linking with any of the two charges, that will, in presence of dielectric, increase.
Okay.
If there is no dielectric, it will be less on quantum than when there is dielectric, and the total is to remain.
Yes, sir.
That'll lead to a conclusion, I presume. You can think over it.
Okay, sure. I'll reevaluate this. Okay, that's Q1, that's Q2. In the absence of a dielectric, I mean, everything's hunky-dory. One is required. How does the... okay, wait. Talking from a purely field lines point of view, how does the dielectric change this configuration?
Dielectric will change the density, which is in the area bereft of dielectric, because the total number should increase. Dielectric now present between the two will allow lesser number of lines to go through it.
Okay.
More will find space
Hmm.
through the other mean.
The other means? What's the other means here?
Finite. From infinite, suppose the lines, let's take one charge here, okay? Now, one charge has got lines coming to it from infinity in a symmetrical manner, okay?
Okay.
If it is negative, right?
Yes.
If it is negative. Now, if one side of the charge is getting occulted, you are occulting one side of the charge by dielectric. So what will happen to the lines? Lesser number of line will pass through dielectric and more will pass through the area which is bereft of it.
Okay, so if this is a low negative charge, the electric field lines will look like this. But if you get a dielectric here, they will begin to look like this.
Right.
Okay, I get that. So if these are equal in magnitude, all the lines coming from one will get absorbed by the other, right?
Yeah.
And if you now put a dielectric in, maybe only these two will choose that path, and these two will circle around from infinity.
So what will happen to the force? You are having more number of line, higher density, higher force.
Then wait one second. They're just asking for the net force experienced by Q2, right?
Yeah. So that force, what will happen to is being asked.
Well, I don't know. Okay, wait one second. Let's forget about the two charges and their fields interacting with each other. I just want to keep one charge here first, right? Let's say this is a positive charge. Once the dielectric comes in, its electric field this way will be more intense, and maybe one or two lines escape this way. Right? And now Q2 is here and it's in this field. Now without the dielectric, the field will be a lot more dense, right? Because a lot more lines are coming this way. But when the dielectric has been put in place, the field has become a bit sparser, so it should experience less force.
Just a minute, how do you conclude that? Less force? I couldn't get that. So whatever the number of lines, total number of lines will remain, right? So you're having more lines to the left of the charge. Left of the left charge and right of the right charge. More number of lines.
Yes, sir, but more number of lines on the side where it doesn't really impact this charge. If we consider this charge to be the source of the electric field and this charge to be a test charge, what this dielectric has essentially done is that it's taken a lot of field lines from this side and plopped them over on the other side. So the density of the field lines...
but the intensity got increased with the charge, right? Previously it was evenly, as you have taken a point charge. So it was an even field.
Yes.
Now what happened to even field means it can have an annual effect. When you're talking of the field with higher density to one side, then what will happen to the force? Density to one side has compounded.
Yes, sir.
The other side density less.
Yes, but no, my point. If this charge was here, and this region, the electric field has increased. I mean, yeah, so it would experience greater force. But it happens to have gotten the shorter end of the stick. I mean, it's on the other side, the wrong side. So it'll experience lesser force because the field line density here has decreased.
Field line got decreased through the dielectric, correct?
Yes.
Total will remain same, correct?
So then, okay, what's the point of the dielectric?
No, dielectric is decreasing the linkage between the charges through it. That number has got decreased. Let us say initially that area was having 10. Now it's having 2.
Okay. So,
but 10
all this thing...
10 which was permeating is still to permeate.
Yes, that's that.
So that'll do 8 to the left side, which was not 8 otherwise. It was less than 8.
Yes, sir. So my question is, okay, fine, the electric field linkage between the two of them will remain the same, sure. And the only thing that has changed here is the fashion in which the electric field traverses the space between the two charges.
Yeah.
How will that affect its force?
Because if you increase number, if you increase the number of line, if you make the field more complicated and strengthened, What will happen to force? You are strengthening the field. We are having more number of lines now.
So number of lines don't change. You just said that.
No, more number of line to the left, bereft, the area which is bereft. Yeah.
Yes.
Then what was with dielectric? That that line, the line which is to the left of the dielectric, the number of lines,
Yes.
they have increased on strength. They have increased on density.
Yes.
Just go by the number of lines. Fine, dear. Previously it was symmetric, let's say. Now you are having one side higher density than the other.
Yes.
So if one side is higher density than the other, if previously the force was X, will it be X even now, or there will be a change on force? That is what being asked.
Well,
Think over it. No hurry. There's another way also that you can employ to it. You can assume it to be a dielectric and capacitor, and then take dielectric polarization into consideration. See what you'll get at the surfaces. Plus minus, and which will be near.
you're basically going from this. Right, let me draw another line and another one, just so that I can make my point later. We're going from this to this, right? Maybe this line still remains, maybe this line still remains, maybe this line still remains, but the rest of them go to infinity and come back from infinity. Something like that, right?
Yeah.
Because
There was 6.
oh,
The number.
Okay, I
Same number.
need to add another one. Sure.
Right.
So this is still a bit off. Like you find the number at okay. What was the other method you were suggesting? To look at the charges accumulated in the two plates.
Let's take dielectric polarization into consideration.
Okay.
The proximity of charges.
Okay, so if
plus minus that base.
This is plus, this is minus. You'll get minus here. You'll get plus here, right? And because of this is being attracted. Because of this is being attracted. And because of this is being repelled. But since this is closer, it'll attract it more. So okay, that means force should increase.
Yeah, it does.
All right. I'm convinced with this, but the flux thing still bothers me.
Think about it. A number of lines.
Yeah, the number of lines idea. I'll give it some thought.
Okay, fine. No issues. And this one, the disk one you spoke about, right? You wanted to check for the disk one, this induction.
Yes.
Pulley, I presume, fine, right?
Sir?
You got minus or not in pulley?
Yeah, I did. I took mod here, and when you removed the mod, I got minus. I mean, initially I hadn't got it, but then I realized I had to incorporate minus somewhere. I just thought I'd throw it in here.
Yeah, okay. Okay. Can you show me the FBD for pulley one once?
So the FBD for the pulley.
Yeah. E plus dt delta tt. Okay, friction.
So I've considered this. Where'd it go? Yeah, I've considered dt itself to be friction. I mean, the little change in tension that is due to friction, right?
Okay, so mu into normal, right?
Yeah, that's what I've done.
Okay, done. That one, that rotating one, which you said there's no option correct. Where is that one?
That's this one.
No, that was electromagnetic induction one, right?
Oh, which one are you talking about? That's the only thing that's left that I have a problem with. Everything else is clarified, I think. Yeah, this one I'm still working on that. I haven't completely read LC oscillation yet, so once I do that, I'll get back.
It's not LC oscillation. It has not got anything to do with LC, otherwise I've not gotten it.
So
it does. Not an LC.
It does?
No, it's not. Right.
So
why will there be?
It clearly incorporates
that quantity is required, omega is required. That is fine.
See, you can't just say doesn't have NC oscillation. It clearly uses concepts from the thing.
Omega, no. Omega requirement is different, yeah. Omega, you know omega is equal to 1 by LC under root, right?
Yeah, but you only derive that once you derive all the equations for the LC oscillation. Once you get current or charge as a function of time, only then you can say. I mean, once you get charge as a function of time, from there you can get omega, right?
What is that a rocket science? What is there in it, by the way? You know L, you know C, isn't it?
As I
So
hadn't done
LC
that, so yeah, I'll saw that again once.
required to do that. Yeah, LC oscillation is just a topic taken. LC oscillation is very much part of inductor and capacitor. Additionally, we don't require much to do in it. What do you do? Either you do by energy or you do by KVL, correct?
Yes, sir.
Anyway, nevertheless, that one, which was the other one? There was one more. Hmm. This one, this is the one, right?
Yeah,
So this you said you got. What did you do? You've taken a small strip.
Yeah, I first calculated the torque it would take to counter the friction. I mean that would be the kind of does this sometimes, unless you like put a dot somewhere there and you can undo that. It just oh god, it jumps to the last position.
I'm not someone. Right.
Yeah.
I was talking about that one first.
So?
That rotating M1, M2, two gob given to you, and there is a ring. Where is that one?
I don't recall seeing that problem. Did I miss it? Was it this one? This one.
Yeah.
Okay. I didn't see this one. I must have skipped it.
Okay. Give a shot to this one as well.
Yeah, I'll try this.
Okay.
This is the only thing that's remaining. I mean, yeah, I calculated the torque to keep it rotating. I mean, that's irrespective of the magnetic field. This would happen anyway. I think it's a question of its own in RBD. So, there's a disk rotating on a rough table. How long will it take for it to stop? That kind of question.
But this is a Irudov, right?
Yeah, and from there, the EMF across PO would just be B omega L squared by 2. I mean, classic form. And from there, you can get current as a function of time. This is from the LR circuit. From derivation, current as a function of time. Let's just plug that in here because the EMF is constant.
Okay.
So I got this matched the options, but this didn't. So I was just a bit confused about it.
No, that's fine. The option may not be correct.
All right.
You're getting B omega R square by 2R, right? 1 minus it is RT by L.
So?
B omega R square by choice of capital R 1 minus e raised to RT by L, right?
Yes, sir.
That's correct. And then the energy one, what is total? This also is fine. Right. You're not getting any option correct there. That's okay.
All right.
That's just fine. So this, why did I write? Just show me. Anything that you missed? What were the options? Other options?
Okay. Just a second. I think it's somewhere over here. No, not that one. Okay, I'll have to go to my downloads and open up every single one of them. I do think there's a quick view feature here. Just give me a second. Yeah, okay. Recent range by date last added. Sir?
Chetan Bhagat on your shelf?
I wasn't reading it. You see that I have this friend called Samarth back in Ireland. He keeps always reading these cheesy romance novels. He forced me to try this one. I just made it through the first 2 chapters. It was actually a while ago.
Okay.
Wait, just a second. Yeah. Another one. No. Yeah, there we go.
Which is the foreign authors which you go for?
Foreign authors. Actually, I'm not much of a reader, but when I do, currently... sir?
Tolkien, Rice? You don't? Ayn Rand? No.
I'm not much of a fiction reader, actually. I prefer to read. I prefer to read books which are a lot much. I mean, they don't demand a lot of your time. It's the same relation that's between movies and TV shows. You prefer movies because you can sit at and do it in 2 hours and let go, and you don't get addicted to an entire series
That is
that you just
for
realize later spans
novel.
6 seasons.
That is true for NOVEL, as you are saying, novel.
So, I didn't catch you. So I think you went to WhatsApp again.
Ah, that is. Am I audible now?
Yes, you are.
I said I'm not referring to NOVEL novel as they say something new. I'm referring to philosophy. What they philosophize, wherein they want you to use your intellect and come to a conclusion. The different philosophy altogether. Ayn Rand, AYNRAND.
Anne Rand, yeah, I've heard of her. I think I've got one of her books. The waterfall, the
Fountainhead
fountain,
or
the something.
Atlas Shrugged. Fountainhead, one is Fountainhead, the other
Yeah,
is Atlas Shrugged.
yeah, I've got the Fountainhead. I've got that book.
Yeah, Fountainhead is a very good one.
Although
It should pique your interest. If it piques your interest, then you can go through. It's a good one. And Tolkien also is a good writer. Well,
Tolkien. Yeah, sure, but the problem is most of my reading is quite academically motivated. I think I do have a reading list somewhere here. Yeah, that's the kind of stuff I read mostly.
would like to share this with me?
So share what?
Can you get me the screenshot of this one? Where
Uh,
I can also go through these.
Yes, sure. I'll just send that to you. I mean, that's actually supposed to be my journal.
Let's pique your interest. Okay.
Right, so yeah, that's
Yeah.
currently on my reading list right now. Haven't touched any of them, but I plan to.
Yeah. So what next?
Right now, I'm just gonna do some chemistry. So that's alright.
How is it going, Vasudev? About third of September, right? Sorry, September, October first week will be out. 29th it is, right?
So what's 29th?
RMO?
If I get in, although right now my score stands somewhere between 20 and 25, just on the cutoff. So I have like, sir,
You'll be through. 25 is okay.
20 to 25. So I think
Karnataka, right?
yeah, it's pretty much a toss of a coin if I get in or not. And so, but I'm also happen to be in 12th grade, so I think the cutoffs are generally higher for 12th grade.
Well, that's true, but still, I would say it's a nick and butt. That's they say. Very close.
Yeah, I actually, even if my projected marks was 40, I've done some incredibly stupid mistakes. Like for example, there was.
You said 42, if I remember it correctly.
Sir?
You said 42 other day?
And okay, that was accounting for a 2 marker, but then I got that wrong. So then it was 40. But then it came down from 40 to 25 because I've done the stupidest of mistakes. For example, there was this 5 marker which I spent some 15 minutes working out. I got the solution, but they'd asked for natural numbers and I counted 0. So instead of 54, I got 55. It's just blood lurching. If I can't find a better word to describe how that feels. To count to 0 when they ask you to count natural numbers. I mean, yeah.
That has brought you to nip and tuck, dear.
Sir?
That has brought you to nip and tuck case.
I didn't get you.
Nip and tuck. Nip and tuck.
Nip and tuck. What does that mean?
I thought it was 42. I accordingly did tell my child it's 42, your case.
As the speculative, like I've lost all those 15 marks just because of mistakes like that. Like, just because of mistakes like that. Closely
Nevertheless-
contested, neck and neck. Okay, got that.
Okay.
Yes.
Fine. So you're preparing for it, for RMO, right?
Yes, I am preparing. I mean, I will, just in case I do get through. I just don't want to be left with 1 month to prepare.
And NSCP, did you opt for?
NSCP, yeah, I've registered for NSCP. I'm also planning to register for the IOI. I mean the local qualifier version of IOI whenever the registrations do open. I think it's called the ZCO. Indian Computing Olympiad. The registrations haven't started yet by the looks of it. When it does.
NSCP is up, right?
Sir?
NSCP is up. That is done, right?
It should be. I applied for a bunch of Olympiads while I was applying for the IOQM. I might have done this too. I'll check my mail. If I have not, I'll register for it today.
Yeah, do. Fine, then let's keep to this today.
Yes, sir, sure. Thank you.
Okay, thank you, bye dear.